Is this what you're saying? Record? Yes. Okay. All right. So let's go ahead and get. So this is your SAS assignment two. Okay. And here's the parameters using the ANOVA data set. So you have to have the ANOVA data set downloaded. So again, you're going to download. Click this to download, but don't try to open it on your computer. Just leave it somewhere where you can upload it into SAS. You're to run a two-way ANOVA exploring the effects of gender, white race, and white race on physical activity support, controlling for physical activity enjoyment. You are to test all two-way interactions. Your research questions are one, does gender affect physical activity support after controlling for the effect of physical activity enjoyment? Two, is the effect of gender, if any, moderated by race? White versus non-white. Okay, so moderation means there's an interaction term. So you want to see it, does the effect of gender on physical activity enjoyment differ for white versus non-white individuals? That's what your question is. Okay, so that's what we call an interaction term. And what we're doing here is to do this, this isn't a simple ANOVA because I introduced something in here called a covariate. So I said you're going to control for the effect of something, right? Controlling for physical activity enjoyment. So we want to know, okay, hey, what's the effect of gender on physical activity support? Basically, right? And then race on physical activity support. Physical activity support means that people are supporting your physical activity. Like, hey, you like to do physical activity, therefore I'm gonna cheer you on or give you money to buy stuff. So support, right? Drive you to your events, etc. And the idea here with it may be a difference based on gender or race. And it's possible that there could be an interaction between gender and race. So you see the effect of being female would differ between white versus non-white, etc. So that's what we were looking for here. All right. So this isn't going to be a simple ANOVA. If it was just a simple ANOVA, it would be just one of these variables that had more than two groups, right? If we have two groups, then we can use something called a t-test, right? But even though each of these has only two groups, right? You have race has two groups in this case, and gender has two groups, but two times two is four, so we end up having four groups, right? So it becomes an ANOVA situation. So anytime you have two independent variables, right? Whether or not they have two groups to them, if we're putting them together, now all of a sudden we're going to have more than two groups. So that's why we can't just use, right? Oh, that's why we can't just use a simple ANOVA. We have to do something different, and that's where we're coming in here using something called proc GLM, general linear model. Okay, but first thing we want to do is provide descriptive statistics. You always want to provide descriptive statistics. So you're going to provide frequencies and percentages for gender and race, right? So you have to that's a proc freak. So I'll go over that again. That's a proc freak. And then you're also going to want to provide means and standard deviations for the two continuous variables, physical activity support and physical activity enjoyment. And then you're going to run the model. So this is what the model actually looks like. This is a regular linear model, so that's why it's called a general linear model. It means there's an intercept, like with every line, there's an intercept. There's effect of being male versus female, non-white versus white. So you'll notice that I just wrote one of those down here. So we're gonna make male versus non-male, male versus female, non-white versus white, and we're gonna look at the effect of those being in those categories compared to the other category, creating dummy variables. Enjoyment, that's a continuous variable, right? And then we have all of these interactions, male by non-white, male by enjoyment, non-white by enjoyment. So those are actually products, they're multiplications. And then we'll be able to test that. We're going to provide a plot for the physical activity support with gender on the horizontal axis and different lines for race, and interpret the results focusing on the interpret. So when you interpret anything with an interaction, the interaction always takes precedence. So if the interaction is significant, you do not interpret the what they call the main effects. Like here, for instance, if a non-white by enjoyment was significant, you would not interpret non-white and enjoyment by themselves. Even if these two are significant and this is significant, these are irrelevant. If this is not significant, but these are significant, then you interpret these are called main effects. So is there a main effects for race? Is there a main effects for enjoyment? Main effect for enjoyment. But that's only if the interaction is not significant. And then we provide effect sizes. Now, what I did here was in SAS, I did a sort of a very similar analysis. I didn't do the exact same analysis, but I did a similar one. So let's go here. Could they save this? I log out of here. That's from my other class. We are in 704. There it is. All right. It's the ANOVA data set. And here it is. So now you always have a programming file. For some reason, I like to call my files essential file because it's essential. And without it, I wouldn't be able to do anything. So I just keep this file. And here's SAS assignment 2, but I did it a little bit different. So I am using the ANOVA data set. So just to be clear, to if you can't remember how to do it, to download the data set, you'd find the folder in which you want to keep the data set. You right click and have upload file. Then you upload the file wherever it is. Like in this case, I'm uploading, I don't know, I don't know where I kept the ANOVA file. Maybe sometimes I just keep it in the downloads because I don't really need to save it. So I'll just upload it from there, right? But you upload it into SAS, and once you upload it, you have to import it. Like for instance here, this one, once it's uploaded, so you see here it says ANOVA 2. Evidently, I must have had another one in there before. ANOVA2.sav. .sav is an SPSS file, and we're in SAS now. We're no longer in SPSS, so this can't work in SAS. So what I do is I import it, and this will actually convert it into a SAS file. Okay? And I've already shown you how to do that. If you don't know how to do it, please just watch one of my videos. Once that's done, you'll have a SAS file, ANOVA.SAS, and this one has 7BDAT. That's been really common, but doesn't have to be that. But everything that we're going to work with will have this SAS 7BDAT. So this is my data file, okay? And my data file is located. It's weird with SAS, we have to work through libraries, and our library is I created a library called PHLT 704, and you'll see that that data set ANOVA is in there. But so when I want to call up ANOVA, I'll have to say PHLT 704.ANOVA because it's referring me to this library and to the file name, which is ANOVA. Okay, that's a start. Now, so I did something probably a little bit different here. Let's see. So instead of my dependent variable, so in your assignment, your dependent variable is support, right? And then the control variable was enjoyment. So you can see here, I didn't do that. I changed it, but this is just because I don't want to do your homework for you, right? So what I did, I changed it to where my dependent variable is minutes of moderate and vigorous physical activity per week. And my control variable is physical activity support. So this is what's called an ANCOVA, analysis of covariance. So the idea of an ANCOVA is you have the dependent variable, and we're going to clean it up. So what we want is to see what the effect of our predictors are on that variable itself. But sometimes that variable can be a little dirty because it's also related to things like physical activity support. So the idea is, can we clean up that variable and remove whatever shared variance, like the R square, the shared variance it has with physical activity support? Let's get that out of there, right? And we should have a cleaner variable. So we have cleaner variability in this. So that's why we included why we included physical activity support here. Now, one of the issues is one of the assumptions of this analysis is that physical activity support will not be related to whatever my independent variables are. So it should not be related. So there should be no different no difference in physical activity support between females and males, right? In its real in the let me just repeat that. There should be no difference in the effect of physical activity support on moderate to vigorous physical activity for males versus females or for non-white versus white individuals. So that's one of the assumptions. However, that often doesn't hold, right? And when it doesn't hold, you don't throw away the analysis, right? What you do instead is you interpret it because it might be something interesting. So that's what we're going to do here. Okay, so this is just like your assignment. Everything else is just like your assignment. Okay, so for your assignment, it'll say model and it'll say physical activity support equals, and it'll say enjoyment, but then you'll have female, white race. Those are the names of the variables. This is my way of naming variables. Whatever the variable one is, that's what I would put here, right? So one was female, in this case, one was white race. Then we have the interaction of female with white race, female with physical activity support, and then white race with physical activity support. So to do these interactions, I just literally do this, right? I just throw an asterisk in there to make a multiplication sign, and that creates the interaction. And that's one thing I really love about SAS. I don't have to code another variable for the interaction. I just throw it in there. All right, so let's go up here where it says class. Class is a statement that say, hey, I want to create dummy variables here, right? Now, I don't have to do anything here because my variables are already coded 1, 0, right? But if I want to, I can do this. If I want to know what's the effect of being female versus male, I can add reference category equals 0. So it's going to compare. I think I have to do this actually. We'll find out in a second if I'm wrong, but I think I have to put these single quotation marks around it. But I'm saying, okay, my reference value is 0, so we're going to see what's the effect of being female versus male on moderate to vigorous physical activity. I do the same here for white race, right? I do ref equals 0, ref equals 0, and it'll do the same thing. It'll always look at 1 versus 0, and I think I need those single quotation marks again. All right? So those are my categorical independent variables. Next, I told you about the model. This is the model. This is the model we're testing. Um, and then I ask for effect sizes. So it's going to give me the effect size that I need. And what I'm looking for is something called an eta square or a partial eta square. Partial eta square actually just looks at the proportion of the variance that's accounted for by a variable, right? And that's what we want to know. It's just they call it eta square. Partial versus regular eta square. Partial eta square is the better one that you want. And then what we want is the parameter estimates. Like we want the B values, right? Like in a regression analysis, that's what the solution thing will give us. Here's the part that we're going to need later. Now you normally wouldn't need this store model fit, but I asked you to draw these graphs. So when you have interactions, it's really important to draw figures because it's hard to interpret without a figure. So we're going to draw a figure as well. And here's how we're going to draw them. So we're going to run this first, and we'll find out now if those if this is right where I had them in single quotation marks. I'm pretty sure it is. So I'm going to run this. So this is again assuming that I have my ANOVA data set in there. So let's make sure everything works. It'll tell me if I'm wrong. Let's see, go under the log, and there's no errors. Look, no errors, no warnings, no notes. Beautiful, right? So I ran it, and my results are here. Okay. So let's take a look at these results. So this is your prototypical ANOVA table. You remember the ANOVA tables. You have the sums of square for the model, the sum of square for the error, degrees of freedom for model, degrees of freedom for error. Everything has to add up to that last line. Then with the mean squares, that's this value divided by degrees of freedom, this value divided by degrees of freedom, and then we have the F value, which is this value divided by that, and you have its P value. So this is telling you that there is a difference somewhere in this model or that the model is significant, but just doesn't tell you where things are occurring. Here's our eta squared. So this is our eta squared. Well, this one does give us a partial, just gives us the eta squared, not the partial eta squared. But that's good enough. They have the same heuristics, which I can't remember off the top of my head, but luckily for me and you, we can just look it up real quick. So let's see. Uh, Eta squared, rules of thumb. I hate to use that word, but rule of thumb. All right. And it'll just tell you like small is zero point 0.1, medium is 0.0, 0.01, 0.06, and 0.14. So we can just compare that to what we have here. All right. And 0.14. So it's, I guess that's pretty big, right? Isn't that what it said? Yeah. So this is right there at the edge of a large effect size. That's pretty cool. So we have a large effect. All right. And then the other thing we want to look at really is the parameter estimates. Let me see, where are they? Parameter estimates here. Yeah, parameter estimates here. Actually, centrality. This is the one I wanted here. Sorry. These estimates here. So I'm going to look at these estimates here. These parameter estimates. So this is your intercept, then it's standard error. We don't really care much about the intercept. Whether it's significant, we know physical activity support has a significant effect on physical activity, right? Each unit increase in physical activity support resulted in a 46.915 minute increase in minutes per physical activity per week, holding all other variables constant. The usual interpretation. These are in t values, right? Because you're comparing some value to a, mean of zero, right? A population mean of zero, so it has an effect. So that's significant. Look at female. So look at this. It's female 1 versus 0. Okay, that's what we wanted. Female versus 0, which was male, right? So there's a negative effect here, but it's not significant. So it can ignore that. Race by itself is not significant. Can ignore that. But what we want to do is look at the interactions. And in this case, none of the interactions are significant. Again, this is just an example to show you how to run it, but I'm looking here for a significant interaction, and my p-value is really this. So this is race and physical activity support. P-value is really large. It's really, really large for gender by physical activity support. And then gender by race, it's not significant either. So my p-values are large, right? With what we want is the p-value, the probability of the observed result or greater given the null hypothesis is true. We want it to be small, like less than 0.05 at at the worst, right? And the best would be even better, smaller values, and we don't have anything. So I can go back and interpret things like physical activity support, and we see that it has a significant effect, right? Physical activity support does have a significant effect. So you can go ahead and interpret that. But that's the only thing, though. Any questions? So if I heard somebody. Okay, so yeah, so then what we want then is we want to look at yeah, you just want to look at this table here for the results. Okay, let's look at the interaction. Well, in this case, I don't like this right here. I don't like it at all. So that's why I drew the other interaction. This is what's produced automatically because it seems really messy. It almost looks like some kind of a futuristic computer screen where like data are dropping down. So instead of doing that, I go to this other plot here, which I did here. So we save the model fit data from this analysis, and then we're going to pick it up here. So proc PLM, restore the model fit, and then we're going to do a plot. We're going to plot an interaction where the x-axis is going to have female, which is 1 is female, 0 is male. And then we're going to have two separate lines. And our output here is minutes of physical activity, but we're going to slice it by race. All right. So we're going to go ahead and do that. Oh, you get a much nicer, cleaner. Now, there's no interaction here. We can tell because there's no crossing of the lines. That's a telltale sign of an interaction, but it's a much cleaner figure. Look, you have the race here, right? one, and you could manipulate these two and change these to, say yes, no, or whatever you want. You could change that to race, white, non-white. Um, and then here you could do, female, male if you wanted to. But the idea is that it looks really nice, right? So it's much clearer than that other mess that we saw there. Yeah, so that's your data analysis. Again, so here's the code. I mean, this code is perfect for you. And I think I gave it to you, and then I think I gave it to you in one of the lectures. Whenever lecture, yeah, I know I did. Whatever lecture I did with this, I think I gave it to you, and you can you just copy and paste that into SAS, or you can just copy and paste this into SAS, or photograph it and type it into SAS. Okay, but again, you have to have your folder, your library, and your file downloaded. Okay, so questions about this, 'cause I know you might still have questions. Did this help?
Yes.
Yes, definitely.
All right, yeah. So I mean, it's a lot of playing around, and the thing with computer programming and statistics is you'll make errors, but it's not going to hurt you that much. Worst case, it'll say, "Oh, there's an error. This doesn't exist." Like if I did this without that little quotation mark, it would give me an error. It says this reference value does not exist. And you think, okay, well, I must have done something wrong. And so that's what I remembered. I know this because I've been fooling around with this, but you may not have known that. Okay, you could like look it up. I tell you what, AI works really well here with programming. I found it a very useful tool, especially when you're learning a program. Like I haven't used SAS in years. I mean, but been about 12, 13 years since I was using it regularly. And so having AI as a companion has been very helpful. Like, I mean, I think I asked, like, how do you plot an interaction with proc GLM? And this is the code it gave me, and it gave me this whole thing, and then I adapted it to what we're doing. So in this case, if you run into an issue, just do a Google search, and it should like give you what you need through AI, and it'll get you what you need. But so just to be clear, in terms of the assignment itself, so what you're going to fill in here, where were we? So this is to look like a table. So I'd want to make this into a table, right? This is like a 5 by 1, 2, 3, 4, 5, 6, 7, 8, now like 5 by 9 table, right? So then you're going to have an intercept value. And when we go back to SAS, you see where everything's there, right? So everything was there in terms of the results. Actually, the results, go back. This part here, you can see that the results are all there in one of the tables, right? I use that one table at the end here. You see, so basically this looks just like that, right? You have the estimate, you have the standard error, the t-value, and then the p-value. So if you go to our assignment, you'll see most of that there, right? You have the b b is the parameter estimate, standard error, t-value, p-value. Then you can ask for the confidence interval. But that's something that you'd ask for. So in fact, I'm just curious, did I do that here? Yeah, I think I did gave you confidence interval, did I, or did I not? That's a good question. So let me take a look. Did I give you the confidence interval? I think I'm gonna try this. I think this is what you do. See, it may not work. This may not. So if it doesn't work, so let's do an error. It'll show me an error if it doesn't work. So you'll see two errors, right? So it didn't work. See the confidence limit. All right, so let's do a quick example using AI to get us here. Okay. So confidence interval proc GLM GLM SAS and show us where you put it. This is really cool. I love it. Um, CL Parm. There's CL Parm solution. CL. That's pretty cool. Okay. You can also do the LS means, least squares mean group. All right, we can do that too. All right. Actually, I think this is what we want here. These are least squares means. So these are like adjusted means for the groups. Okay, let's do this one right here. LS means confidence limit. Okay, let's do that. Um, get rid of this. I knew it was CL, but just not where to put it. So I think we put it right here. Let's see. LS. Yep, there it is. LS means. And we had group, our grouping variable. I guess we could do female. Hmm. Female W1. And then what's next? That's CL. I wonder if we could do it for both. Let's see. Let's try that. Let's try this first. CL. Okay. Let's try this first. Okay. We've got any errors. No errors. And where's the confidence limits? Okay, here they are. So these are the means for female, right? For female and male and their confidence intervals. Okay, that's the mean physical activity. Okay, that's one thing. All right. Where did I wanted the means for the effects. Uh-huh. Means for the effects. Oh, let's see. I think that might have been in the other one that we saw. I'm sorry, I'm having fun doing this. So, how about solution C? It might be right here. Solution CL parm. Solution CL parm. Let's see if that works. Solution here. CL parm. There it is. Okay, CL parm produces confidence. Okay, that's perfect. That's what I wanted. Okay. So we don't need this one here, but now you kind of know how you could produce them if you need it for the means. All right, let's do this. Let's see what happens. You can see confidence limits there. Here they are. Look, confidence limits. That's what I want. Okay. Now these ones look really big because minutes of physical activity is a large variable, and you're not going to have that same issue with your um variable dependent variable being support. Okay, but you saw what I did here, right? So to get confidence limits, I added CL. So this is confidence limits for parameter estimates. Okay. So I added it to under model. So model. All right. Cool. All right. So that will take care of everything you need to do. It's just one last thing to just look. Yeah, that's it. So lower bound, upper bound. Okay. And then provide effect size. So the effect size is the eta squares. Okay. All right. Interpret results. So I mentioned how to do that. There are other questions.
I just have a quick question. You
Yep.
said earlier for the first part of the assignment, like question one, where it's saying like provide a descriptive statistics table, that was just like proc frequency,
Yes.
like kind
So
of how we did last time.
yeah. So I'll do proc freak. We said this was in this case it was female, right? Proc freak. I think was white race, and then proc means for the others, right? Proc means for physical activity support. Proc means, or you could do proc univariate. So proc univariate, if you recall, gave us a whole bunch of stuff, right? And the reason I used that initially was because it provided us with a figure as well. But if you just want to do, you can do like something like proc means. That'll give you the same thing, but like if I did proc means here, so that would just give me one thing only, right? Means and standard deviations. That's really what we need here. That's right. Data equals, and what was this data set? PH LT704 dot ANOVA. Okay. And I see var is what did I say the var? Let's do MVPA par control C control V. All right, so let's do this one real quick. So see, this is unlike proc univariate, it just gives you the mean and standard deviation. And in most cases, this is all you need, right? When we did the proc univariate, I wanted to, I did it because I wanted to produce that histogram, right? And produce the histogram. If I just need a mean and standard deviation, this is all I need. And I can, put both variables in one statement, right? I could do, proc means, MVPA, par, support one. I could put as many of the variables I want, and then proc freak for the other ones. And then so you always have to provide a descriptive statistics table whenever you do an analysis because that's how people replicate. So they say, does my sample look like your sample? So they need the basics. Any other questions? All right, I hope that should give you enough to, get finished. And by the way, if you didn't do as well as you wanted on the exam, you know that I allow you to do to fix the problems that you had and get credit on it. So just just let me know about that if that's something that you want to do. But just send me an email and I'll set it up for you because I don't want anybody to feel panicky. That I saw there were some issues where some people didn't do certain things on the exam. Doesn't mean that you can't do them. I'll always let you guys do it. Other than that, well, spring break's coming up. Anybody got any good plans? Or are you just studying?
Just
I'll be on
studying.
campus, so
You what?
yeah. I said that I'll be on campus
Okay. Well, good.
for lacrosse, so
Yeah. I figured a lot of the athletes don't get spring break, but with one of our guys, I don't know if you know Corbin, he's our one of our athletes. He's up at Lake Placid now in a national championship for our ski and snowboard team, which is really cool. Um,
very cool.
yeah, he did his first thing already today. So we'll see how it goes. But all right, everybody, thank you very much, and I'll see you when we get back. Right?
Thank you.
Enjoy, be
Thank
safe.
you.
Thank you.
Thank you.
Thank
Bye.
you. Dr. Rodriguez, can I talk to you,
Yes,
please?
yes, I
Thank
saw your
you.
message. Take care, everybody else. Okay, what's up?
Yes, so the first assignment, I did try to submit it through the website, but it's not letting me.
For which one? For the assignment or what?
The assignment, the first one. The first one that
Oh,
we did. Because I sent it to you like a month ago on your email, but you said I had to submit it through the website.
so is it because it may be? Let me actually stop the share here.
Okay.
Let me first of all let me stop the recording. Okay.
Okay, okay.
Let me do that real quick here.
Okay.
Hold on. I think I stopped share. Did I stop share? And let me stop the recording.